First, we're just going to have a little bit of quick conversation on how to properly name three-dimensional figures. We'll start first with the prism. A prism is going to be a solid, so we're talking about this whole thing as a solid, right? And it has two bases, base 1 up here, base 1 down below. And those are congruent, right? They're identical bases and parallel. For this particular one, the bases are triangles, and they are congruent triangles. The figure is now called a triangular prism because the bases are triangles. Next, we have a pyramid. And what is a pyramid? Again, it's a solid with one base. So this would be a triangular prism because it has a triangle base. So again, that base is what is the first part of the name. And the key difference between a pyramid and a prism, one base, and then the faces, right? So here's one face here and another face there, and there's a third one in the back. They all meet up at one point. That's what makes that a pyramid. A cylinder is essentially just a prism that has circular bases. So anytime circles come into the picture, we give it a fresh name. So a cylinder is just a prism with circular bases. Cone, very much, it's just going to be a pyramid that has a circular base, and a sphere essentially is a ball. Right, so these are all solid three-dimensional figures. Okay, so our first point of business is to simply classify. So again, don't forget to highlight the base. This base is a rectangle, and all of the faces meet at one point. So it's some sort of pyramid, and which type is determined by the base. So I would say that this is a rectangular pyramid. Right here, again, this looks like another type of pyramid. We're going to say this is a pyramid. What type is determined by the number of sides. So I'm going to count 1, 2, 3, 4, 5, 6. So I guess this is a hexagonal pyramid. Now, if you don't know the fancy ending, you could just say hexagon pyramid. It's grammatically incorrect, but it's not, totally incorrect. This last one looks like it has a base in the front and a base in the back. So this front guy here and then the back one there, those are the parallel bases. And it looks like they are trapezoids. And because there are two trapezoids, two bases, then I guess this is a prism. And so really we should call this a trapezoidal prism is the official name. You go ahead and finish the other remaining problems. You should have 1 through 12 all done. Then move on with the rest of the notes. Stop and complete the rest of the identifying. The remaining portion of this video is going to be dedicated to finding the surface area. And so really, it's just taking a bunch of surfaces and finding the area of the individual surfaces and adding them together. That's all we're really going to do. So when we look at rectangular prisms, again, there's a base over here, and there's a base over here. Base doesn't mean bottom. And so these things are rectangles, so this is a rectangular prism. So there's two of those. Then it looks to me like there is a top and a bottom, right? So there's a bottom and a top to this thing, and there's two of those. And then there's sort of a front face and a back face. So there and there. And there's two of those. And these are all rectangles, right? They're all rectangles. So really there's 6 rectangles. And we're just going to find the area of all 6, and we're going to add them together. But there's 2 of one flavor, there's 2 of another flavor, and there's 2 of another flavor, which give us 6 individual rectangles. And by flavor, I mean that there's a left and a right side, they're identical. There's a top and a bottom, they're identical. And then there's a front and a back, and they're identical. So we'll put BOT for bottom. So all we have to do is identify these features, right? So I guess there's a length, a width, and a height to this rectangle. And what we're going to end up doing is pairing these things together to figure out the overall dimensions of each of these 6 rectangles. And let's move on to an actual example and put this together. We'll note that this right here is the actual formula. You're going to want to fill that in on your sheet. But I don't think that you need to memorize, right? So don't memorize this. Try to make sense of this thing. The following figure isn't in your notes. I just want to be able to talk through a problem for a second without you having to worry about writing anything. So at the top of this thing, we have this box up here. We have this box down here. It's the same exact dimensions. So where is that in this? Now we refer to this as the net. This is the rectangular prism if you unfolded the whole thing, kind of like undoing a pizza box. And so what we notice is that this is a 3 by 2. So where's that 2? That 2 is here, and here, 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 and this is the 3. So it looks like we have a 2 by 3 rectangle, right? And there's 2 of them. Then we go to the sides over here. Oops, I guess white won't work on the white background. The 2 sides, these green sides. And again, that's a 2 by 6. So where's that? That's 2, 2 by 6. And then here's a 2 by 6. So that's 2 by 6, and there's 2 of those. And we're going to add that to the front and the back. So you got the front and then the back here. And what's that? That's these 2 pieces here. And again, what's that? You can see that this is a 3 by 6. So it's a 3 by 6, and there's 2 of those. So the total surface area is going to be all that added up. So if I just grab a different color, that's going to be 2 times 6 plus 2 times 12 plus 2 times 18. So that's going to be 12 plus 24 plus 36, which gives us 72 square centimeters. Remember, this is area, and area is 2-dimensional, hence that 2. So the overall surface area, you know, if we were to buy gift wrap and we want to wrap this package, if we wanted to paint it, we would need enough paint to cover 72 square centimeters, which wouldn't be very much paint, by the way. All right, let's try something directly from your notes now. Follow along and write with me. So here we are on number 3 in your notes, and we have 3 dimensions. And these 3 dimensions make up the top and the bottom, the front and the back, and the left and the right. Now, you don't have to name them the way I do. You can call them whatever you want, but I'm just trying to keep some semblance of order. So let's start with the top and the bottom. That's this part right here. So it looks like I need the dimensions that go deep that way, and lengthwise that way. So it looks like that's an 11 lengthwise and 6 inches deep, right? So 11 inches and 6 inches. And remember, there's 2 of these. Now we move to the front and the back. So that's this little sliver here and this little sliver here. So that's a length and a height, right? So again, I think it's going to be 11 inches long and 1.5 inches high, and there are 2 of those. And lastly, we're going to have the left and the right. So that's the sliver on this side and the sliver on this side. This looks like a shirt box at Christmas. And I think that that's going to be 6 inches deep and 1.5 inches high. Now, if you look at what's going on here, essentially we have everybody paired up at least once. So there's the 6 and the 1.5, and then there's the 11 and the 6, and then there's the 11 and the 1.5. So we kind of paired them up with each other a couple of times. And now we're just going to go ahead and slowly do the multiplication. So that's 2 11 by 6s, added to 2 11 by 1.5s, added to 2 6 by 1.5s. So you go ahead and finish that one up, and don't forget that that's going to be square inches or square inches. Right? Either way, make sure you have your units along with your numerical final answer. You finish that one up. Now for our next example, you're going to go ahead and fill out the portion that I've left off. And again, I don't know if you want to complicate this, but the lateral area is going to be all of the sides, right, that back side. I know that I have a triangle on the top and I have a triangle on the bottom. So I'm going to take those two triangles, right, the two bases, I'm going to add those areas up, and then the lateral surface area, which is going to be the height between the two bases and the perimeter, right? Because essentially what you have are 3 rectangles, and if you take these sides and sort of unfold them, you're going to get something that looks like this. And the length of that whole thing would be the perimeter going around the base. And then the height would give you the surface area for that whole shell. Or you could just think about it as 3 separate rectangles added together. It's up to you on how you do this. I don't want to box you into this formula looking thing. So again, looking at number 7, what do I see? I see 6 faces, right? One here, over there, on the bottom, on the top, on the front, and in the back, right? And so the front and the back look like trapezoids. The left and the right look like rectangles. And the top and the bottom also look like rectangles. So again, just find the area of each and add them up, and you'll have the total surface area. So let's work this slowly and carefully. Let's start with the trapezoid. The bases are the parallel sides, so it looks like one base here is 10, and the long base here is the same as back here, that's 18. So I know that I have 1/2 times base 1 plus base 2 times height. I know that that's the area of a trapezoid. So I got my 10 plus 18. The height has to come off the base at 90 degrees. That height is 12.4. And then I'm going to have my 1/2. Now this is the area of one of those trapezoids. So first let's process that. So that's going to be 1/2 of 28 times 12.4. Half of 28 is 14, and 14 times 12.4 is going to be 173.6 millimeters. But then there's 2 of them, so I'm going to have to multiply this answer by 2. That gives me 347.2 square millimeters, but don't forget that's just the front and the back, right? Now we need to go deal with the left and the right side and the top and the bottom. So next, let's try to work the left and the right side. So that's going to be this guy right here, and then this guy right here. Well, this is 9 millimeters, so this is also 9, and this is 9. These are just rectangles, and that's a 9 millimeter, and the height of that rectangle is 13 millimeters. So I just need 9 by 13, and don't forget that there's 2 of them. And that gives us 234 square millimeters. All right, that was pretty easy. Now on to the top and the bottom. The bottom is going to be a unique rectangle, and the top is going to be a larger one. So again, sort of, there's the bottom, smaller, and the top is a larger rectangle. So the top rectangle looks to be 18 by, again, 9. The bottom one looks to be 10 millimeters long, but still 9 in width. So we're going to have a 10 by 9 and an 18 by 9. So although there's 2 of them, I can't just simply multiply that times 2. When you multiply those and add them together, you should get 252 square millimeters. Now, for the total square area, add all that up, and get yourself a final answer. And again, that would be the, if we wanted to wrap this box, if we wanted to create cardboard structure to wrap a toy, or to display a toy in a store. I actually knew somebody who that was their business. They designed packaging to go around different items, and one of their clients was UConn. So if you want to display a basketball on a shelf, or if you want to have some sort of a gear wrapped in a box, that's what this guy did. By the way, you should get 833.2 square millimeters. All right, moving along. Okay, so now we're going backwards to number 5. And what do I see? A triangular prism. Why triangular prism? Because it has a base. That's a triangle. And there's one back here and one right here. They're parallel. So we have this triangle. And don't forget that area of a triangle is 1/2 times base times height. So we need that height value. And it looks like that's 4.1. And the base, remember, the base and the height are always connected by a right angle. It looks to be 12. And there's 2 of these guys. So that's going to be 2 1/2 times 4.1 times 12. Okay? So 1/2 of 12 is 6. 6 times 4.1 is 24.6. And 2 of those is going to be 49.2 square kilometers. All right? So for the front and the back, we have a total of 49.2 square kilometers. Now for all of the sides. So you got this sort of top right slanted side, the top left slanted side, and the bottom. So if you had unfolded this side kind of goes like that, and the other side trails off into the distance like this. So the question is, what would be the full perimeter if we traveled around the length of that triangle? Well, it looks like the slanted side over here would be 10 kilometers long. If you travel along the bottom, you're going to go 12 kilometers, and it seems that this side is, probably be helpful if I wrote 12 instead of kilometers. And again, the slanted side over here looks like it's 5 kilometers. So that's the entire perimeter of the triangle. So that's going to give us 5 plus 10 is 15, plus another 12 is 27 kilometers is the full perimeter. If you multiply that times the height, technically this distance that's going back and forth like this, that would be the same as up here. That's 3 kilometers. And 27 times 3 would give us 81 kilometers. So that's the lateral area, or the surface area of all the sides, 81 square kilometers. And if you add that up together, you're going to get 130.2 square kilometers altogether. And you say, hold on, I didn't understand all of that lateral area again. Go over that one at a time. Well, if you just kind of take a look at, say, this one rectangle, that's 3 wide and 5 high. So that's a 3 by 5. That gives us 15 square units. I'm going to add that to the bottom, which is 12 by 3. So 12 times 3 is going to be 36. And then if you add that to this side over here, that's 10 by 3. That's another 30. And if you add that all up, you still get 81. So either you look at it as 3 individual pieces, or the unfolding version, the entire length, that perimeter, times the height, and look at it as one giant rectangle. It's up to you on how you deal with that. But either way, this is 130.2 square kilometers of surface area, all told. Our last solid figure for looking for surface area is going to be the cylinder. So first, we start over here. Here is the cylinder, and what is it? It's a circle on the top, circle on the bottom. But what does it look like when we unfold it, right? What's that net look like? So as we start to break it apart, we're going to sort of cut vertically and start to peel this thing open here along that cut. And the more we unfold it, the more we realize that a cylinder is simply a rectangle rolled up and then topped off on the top. Kind of like a tennis ball container, right? A cylindrical container. Peanuts usually come in a cylindrical container. Can of soup is in a cylindrical container. So a cylinder, we're just looking for, if you were going to wrap a label around the top, the bottom, and all the sides, what kind of surface area do we need? Now here's where you want to pay particular attention. The distance around a circle is called its circumference, right? That distance around. So as we make a cut here and unfold that circumference, there's the circumference laying flat. So this distance here is that length right there. So this length is equal to the circumference, which is equal to 2 pi r. Now remember, that's the length of the rectangle. The width of the rectangle is the height of the cylinder. So the width is the height, right? The width of the rectangle is the height of the original cylinder. So we have the area for this rectangle is going to be the height of the cylinder times the circumference of the circle. And then the area of the two top, or the top and the bottom rather, is going to be the area of a circle to begin with times 2. Take the top and the bottom, and you take your height times your circumference, add them together, and you'll have the total surface area. So again, your lateral area around the sides is going to be 2 pi r times h, right? The circumference times the height. Take that portion of the game, add that to 2 areas for the top and the bottom, and you got yourself the total surface area of a cylinder. Okay, again, let's put this into action. So here's what I notice. I notice that the circles are on the left and the right, and it has a diameter equal to 15. First thing I want to do is get the radius, which is half of 15, right? Radius is half of your diameter. So 7.5 meters is the radius. So let's get the area of the 2 circles. That's going to be 2 times pi r squared. Right? I'll do the first part. So this is the left and the right. Right? The area of the left and the right of this cylinder. Sometimes that's the top and the bottom. Guess it depends which way the cylinder's lying, up or down, standing up or down, or laying on its lateral side. And so that's going to be 2 times pi times radius squared. That's going to be our ladder, or that's our top and the bottom, or the area of the circular portions. I'll apologize for saying top and bottom because I'm really thinking about this cylinder over here. But the top and the bottom here is the left and the right on this one. Okay, so we just found the area for these 2 pieces, right? That's our values there. Now we're going to add that to the area of the sides. So the circumference, right? 2 pi r times the height. Okay. So I know that my height is 9. So that's my height number. And again, 2 times pi times the radius, which is 7.5. So all I'm going to do is just a bunch of multiplication. And I'm going to deal with this exactly as I see it. So I'm going to come in here. I'm going to deal what's inside there first. So I'm going to say, I'm going to use the pi key. Pi times 7.5 squared. I get about 176.71. So 2 times 176.71. And add that to 2 times, I'm going to use the pi key again, times 7.5 times 9. Over here I get 424.12, rounded to the nearest hundredth. Now I'm going to add that to 2 of the 176.71s, right? I'm multiplying here and adding that all at one time, and I'm going to get 777.54. square millimeters. And that, my friends, is how it's done. Now, I would say most of the problems we did in, sort of forwards version. Now, how do we pull this apart? It says that the surface area of a soup can below is 51.84 square inches. So there was 2 circles, 2 pi r squares, and I added that to 2 pi r, the circumference, times the height. And what do I get? 51.84 square inches. All right. It says if the diameter is 3 inches, find the height. Well, if the diameter is equal to 3, and my radius is equal to 1.5. So anywhere where I see r, I can put in 1.5. 1.5. So that's 2 times pi times 1.5 squared plus 2 pi times 1.5 times h equals 51.84. Now what? Turn this into a number, subtract that from your total, and you'll be equal to 2 times pi times 1.5 h equals some value. Okay, and I'll give this a little value scribble. Now what? You can make this all turn into a number. So that'll be something times h equals that scribble. Divide by this scribble, divide by that scribble on both sides, and you should have the value of h in inches. So this really isn't that challenging. It's just a matter of moving slowly and carefully. See if you can finish that one up. All right? Best of luck. Work slow. Ask lots of questions.